A powerful burst of gamma radiation lasted a mere half second, but it released an enormous amount of energy. It was more than our sun would produce in 10 billion years. This brief flash lit up the whole sky. Afterward, a much softer and more long-lasting glow replaced it. Astronomers examined the phenomenon with X-ray, radio, optical, and infrared waves. It turned out that people had finally seen a newborn magnetar for the first time ever. It was likely formed after two neutron stars had merged. It resulted in a kilonova, one of the brightest and largest stellar blasts. Its light finally reached our planet on May 22, 2020. Imagine a massive star, at least 5 times the mass of our sun, reaching the end of its life. It might be because it's run out of its nuclear fuel. If it happens, the star starts to cool off. The pressure inside drops, and the gravity starts to squeeze inward. And then, more than 1 million times the mass of our planet collapses within 15 seconds. It happens so fast that an enormous shock wave causes the outer part of the star to blow up. It produces a blinding burst of light. This powerful blast is called a supernova. What's left behind is an incredibly dense core with a huge cloud of hot gas, called a nebula, expanding around it. If the star has been massive enough, more than 10 times the size of the sun, it's likely to turn into a black hole. If not, it turns into a neutron star. It's basically a giant nucleus, the central part of an atom. These stars are mostly made up of neutrons and are rarely larger than 20 miles across. For comparison, our sun is almost 865,000 miles across, which is 109 Earths put side by side. But don't let this relatively tiny size fool you. Any neutron star is at least 1.5 times heavier than our sun and has an intense magnetic field. If you scooped just a teaspoon of this star's insides, this matter would weigh more than 1 billion tons. It's so dense that it makes neutron stars some of the most extreme objects people know about. The next stop is the black hole itself. When two neutron stars merge, they most often create a new, much heavier one. Within milliseconds, or even less, this star collapses into a black hole. But the astronomers who examined the flash of light recorded in March think there might be another outcome. They're almost sure they saw something never observed before: the birth of a magnetar. That's a rare form of a neutron star with an ultra-strong magnetic field. It's 1,000 trillion times stronger than our planet's. This field is also so powerful, it heats the star's surface up to 18 million degrees Fahrenheit. To put it simply, magnetars are the most powerful magnets in the universe. Their magnetic fields can seriously mess with the neighborhood. Atoms, unlucky enough to get close to such a star, get stretched into pencil-thin lines. If you somehow found yourself several hundred miles away from a magnetar, it would end badly for you. The magnetic field would first disrupt your bioelectricity. It means that your nerve impulses wouldn't work anymore. Even your molecules would change under the influence of the star's field. In the end, you'd pretty much vanish. If a magnetar flew within 100,000 miles from our planet, it would wipe out all the data on every single credit card in the world.
When you look at photos taken from spaceships or the International Space Station that show sunlit objects like Earth or the Moon, something seems wrong. Space looks too empty. No magical scenery of a nighttime sky full of stars. It would be incredibly boring to go stargazing in space, since the sky is always dark. During the daytime, the sky on our home planet is blue because of the diffusion of light. It happens when sunlight goes through the atmosphere. But if you were on the moon or somewhere else in space, there would be no atmosphere to spread this light around. That's why the sky there would always appear black. But it doesn't mean less bright out there. If you were looking out the window of the space station, you'd see just as much direct sunlight as you would gazing out of your apartment window during a cloudless day, maybe even more. When taking a picture on a sunny day, you'll probably use a short exposure, together with the narrow aperture setting on your camera. This way, just a short burst of light will get in. That's similar to how our pupils contract in sunlight so that they don't have to deal with too much light. And since it's just as bright up there in space, the process is the same when you take pictures of sunlit objects there. Using short exposure, you can get good, bright pictures of Earth or the surface of the moon. But it also means there will be no stars in the picture. Even up there, stars are relatively dim. They don't emit enough light to show up in photos taken with such settings. Our home planet has a blue sky that slowly transforms into a beautiful orange-red palette at dusk and dawn. But if you ever get a chance to watch a sunset on Mars, you should expect the opposite, an orange-brown daytime sky that gets a bluish tint at sunset. First of all, Mars is farther away from the Sun than our planet. So, when you're looking at the Sun from the Martian surface, of course, it looks fainter and smaller. And not just that, the Sun observed from Mars is just a bluish-white dot surrounded by a blue halo. The thin atmosphere of the red planet contains large dust particles. They create an effect called scattering. It occurs when the diameter of particles in the atmosphere is almost the same as the wavelength of the scattered light. This effect filters out the red light from the Sun's rays, so only the blue light would reach your eyes on Mars. How come Earth doesn't have rings? All gas giants in our solar system, Jupiter, Saturn, Uranus, and Neptune, have such rings, whereas the rocky planets Mercury, Venus, Earth, and Mars don't. There are two theories about how rings can appear around a planet. They might be just some material left from the times when the planet was forming, or they may be the remains of a moon that got destroyed by a collision with some space body, or torn apart by the strong gravitational pull of its parent planet. The gas giants formed in the outer regions of our solar system, while all the rocky planets are in the inner part. So maybe the inner planets were more protected from potential collisions that could have formed their rings. There are also more moons in the outer regions of our solar system, which could be another reason why the planets there have rings. Also, bigger planets have stronger gravity. It means that they can keep their rings stable after they form. Some experts believe Earth used to have a ring system a long time ago. A Mars-sized object might have collided with our home planet, which probably created a dense ring of debris around it. Some scientists think that this debris formed not a ring, but what we know today as the Moon. There's probably a giant planet lurking at the edge of the solar system, far beyond Neptune. Scientists call this mysterious hypothetical world Planet 9. If it does exist, it's probably similar to Uranus or Neptune and 10 times more massive than our home planet. It's likely to circle around the Sun, but in the outer reaches of the solar system, about 20 times farther than Neptune. Another interesting theory says that Planet 9 could actually be a black hole the size of a grapefruit that warps space in a similar way a large planet would. Even though we once thought it was a rare substance in space, water exists all over our solar system. For example, you can often find it in asteroids and comets. It's also in craters on the Moon and Mercury. We still don't know if there's enough water to support potential human colonies if we decide to move there, but some amount of water is definitely present there. Mars has water at its poles too. It's mostly hidden in the layers of ice and probably under the planet's dusty surface. Europa, Jupiter's moon, has some water too. This is the most likely candidate we know about to host life outside Earth. There's probably a whole ocean of liquid water under its frozen surface. It might actually contain twice as much water as all of Earth's oceans combined. Neptune is unexpectedly warm, even though it's 30 times as far from the Sun as our planet and receives less sunlight and heat. But it still radiates way more heat than it gets. It also has way more activity in its atmosphere than you'd suspect, especially if you compare it to its neighbor, Uranus. Both of these planets emit the same amount of heat, even though Uranus is much closer to the Sun. No one knows why. Neptune has extremely strong winds that can reach a speed of up to 1,500 miles per hour. Can they produce this heat? Or maybe it's because of the planet's core, or its gravitational force? There's a monster black hole hurtling through space at a speed of 5 million miles per hour. Scientists located it with the Hubble Space Telescope. They believe it weighs as much as 1 billion suns. It was supposed to stay put in the center of its home galaxy, but some gravitational forces are pushing it around. At one point, this black hole is going to break free from its galaxy and continue roaming the universe. Luckily, it's still 8 billion years away from us. Solar storms are so powerful that they could leave us in complete darkness. Back in July 2012, the strongest solar storm in over 150 years narrowly missed Earth. Coronal mass ejections, or CMEs, are large bubbles of ionized gas. They tore through our orbit back then. If they had caught our planet in the crosshairs, we would have literally been in the firing line. We'd have faced solar matter hurtling towards Earth, damaging computers and causing power outages that would have lasted for months. A surprise solar storm hit us on June 25, 2022. One photographer even managed to capture stunning bright auroras that flashed across the dawn sky in Calgary, Canada, and lasted for 5 minutes. They were caused by the storm. Vampire stars are a real thing. They're part of a binary star, and they can literally drain the life out of the other star in the system. They do it to keep burning for a longer time. It works like this. A smaller star with a lower mass steals its sibling's hydrogen fuel to increase its own mass. This vampire star then becomes hotter. Plus, its color changes to striking blue. This way, it looks much younger. How sneaky. The color of the universe is dubbed cosmic latte. The light coming from our galaxies and stars within them, as well as clouds of gas and dust in the observable universe, have a specific color. It's an ivory tint, pretty close to white. The universe is beige because there are a bit more areas that produce green, yellow, and red light than those that emit blue.
Betelgeuse, a red supergiant. This ball of boiling plasma is one of the largest stars in our galaxy and one of the brightest. It's about 500 times larger than the Sun. But Betelgeuse is pulsating, getting bigger and smaller. At its peak, it becomes 800 times its average size. If this star were a bucket, it would fit about 300 million suns, even though its weight is only 17 times greater. And here, about 500 light-years away, is Earth. We launch our faster-than-light spaceship and set off on our journey to Betelgeuse. A few seconds, and we've already traveled 240,000 miles, and now are close to the Moon. That's 9.5 trips around the Earth. A traditional rocket-powered spacecraft would take 3 days to get here. We're near Mars now. The flight to the red planet usually takes about 7 months. Several rovers are now at work here, as well as the first ever flying drone, Ingenuity. The surface of Mars is 3 times smaller than that of Earth. The planet is also 10 times lighter. People hope to build a human colony here soon. Right beyond Mars, we have to wiggle and constantly dodge space rocks. This is the asteroid belt. It contains debris and space objects of different sizes and shapes. The biggest of them is Ceres. Its surface is slightly larger than the area of Argentina, and its weight is about 1% of the Moon's. The total weight of the entire asteroid belt is 25 times less than the Moon's. Next, we pass gas giants Jupiter and Saturn. These are the largest planets in the solar system. They're also the heaviest, even though they don't have a solid surface. Then, we travel by Uranus and Neptune. They're called ice giants. And at the very edge of the solar system, we see Pluto. It was once considered a full-fledged planet, but now it's not even on the list. After that, we're 4.3 billion miles away from our home. It took the New Horizons space probe about 9 years to get here. Hold on to your seat, we're speeding up! We're passing through the Kuiper Belt. There are lots of asteroids and blocks of ice here. These are some of the oldest building materials in our solar system. Billions of years ago, our whole world looked like a cloud of these asteroids. We're traveling further through dark space and reach the edge of the solar system, the heliosphere. All this time, we've been moving with the solar wind. But now, it starts to slow down, collides with the interstellar wind, and heats up. This is called the termination shock. The Voyager 1 space probe got to this point in December 2004. We're moving to the region where the heliosphere ends and interstellar space begins. This is the heliopause. In 2012, Voyager crossed this boundary and became the first ever human-made object in interstellar space. But the message from Voyager reporting this event came to Earth almost a year later because of the huge distance. It took 35 years for Voyager 1 to travel all this way. And here it is. The probe is as long as a car and weighs like 2 motorcycles. you can see a gold plate on its hull. It's a message from people to potential civilizations out there. It has pictures of Earth's landscapes, recordings of human speech, and our DNA. As of 2021, Voyager has been operational for almost 43 years. The probe has traveled 14 billion miles. That's like 152 Earth to the Sun distances. And it's still making its way through space at 38,000 miles per hour. Now, we're approaching the nearest star to our solar system. It's Proxima Centauri. We're so far from home that even light needs more than 4 years to travel this distance. If we used a traditional rocket, the trip would take us 73,000 years. The reason we wanted to get here was because of an Earth-like planet called Proxima Centauri b. It's 10% larger than Earth and slightly heavier. It lies in the habitable zone of its host star. It means that water might exist on the planet in its liquid state, and there can be life that forms here. But the star itself occasionally produces flares. Recently, its brightness increased almost 1,000 times. During that time, it emitted so much radiation that even if there were some forms of life on the planet, they probably ceased to exist. We're now more than 8 light years away from Earth. The brightest star in our night sky is Sirius. Seriously. It's so bright that you can see it even during the day. But in reality, there are actually 2 stars, Sirius A and B. They orbit around a common center of gravity, and these stars are moving toward our solar system at almost 5 miles per second. That's the same as the maximum speed of a top-of-the-line supercar on Earth. Foot down, and we've arrived at a potentially habitable planet, 39 light-years away from Earth. This is TRAPPIST-1d. Its host star is a white dwarf. It's a cold star, 10 times smaller and lighter than the Sun. There are 7 planets around it, but TRAPPIST-1d is the most similar to Earth. It's only 30% smaller and 3 times lighter, but it has a rocky surface and the temperature here is 48 degrees Fahrenheit. You'd feel comfortable here wearing a light jacket. There might be an atmosphere, mountains, seas, and oceans here, which means this planet might be suitable for a human colony. But it would take about 677,000 years to get here using traditional rockets. And here's our main goal, Betelgeuse. It'd take nearly 8.7 million years to travel here from Earth in a current-day spacecraft. This star is so big that our ship looks like a grain of sand on a giant beach. We have to jump back in time to find out what happened to this star. First, there was a beautiful nebula. It's a cloud of multicolored space dust and debris. Then, it began to shrink under its own weight. In the core of the nebula, a nuclear reaction began. Boom! And the star was born. At first, Betelgeuse was very massive and hot, but it didn't expand and remained stable. Let's look into its heart. The nuclear reactions in the star's core create a lot of heat and energy. This energy produces the force that pushes on the walls of the star from the inside and causes it to expand. But at the same time, the star is very heavy. That's why gravity pushes on it from the outside. If these 2 forces are balanced, the star remains stable. But over time, the star runs out of its fuel, helium and hydrogen. That's when heavier elements in the core join the nuclear reaction. When they burn, they release more energy and heat than gravity can hold, and the star starts expanding. That's what's happening to Betelgeuse right now. It's already so big that if you put it in the center of our solar system, its edge would touch the asteroid belt between Mars and Jupiter. Betelgeuse will continue to expand until it exhausts its fuel completely. Then the gravity will win. The star will shrink in size, and then an enormous boom will happen. A supernova explosion will be so blinding that Betelgeuse will shine brighter than the moon in the night sky. Luckily, Earth is too far away for this explosion to cause any harm to people. A strong stream of matter that will be ejected from the explosion site won't reach the solar system until 6 million years later. Even so, the solar wind will stop this flow, so we'll be safe. Betelgeuse is likely to explode at any time in the next 10,000 years, but some scientists say it won't happen in the next 100 millennia. Back to the moment before the explosion of Betelgeuse, there can be another, more interesting scenario. Gravity might compress the massive core of the star with such force that a black hole will appear in its place. Black holes are the heaviest objects in the universe. They have incredible gravitational force. Even light can't escape their gravitational trap. The Betelgeuse black hole will begin feeding on cosmic dust and whatever is left of the star. All this debris and light from other stars will get frozen near the event horizon of the growing black hole. For the first time in history, we'll be able to watch the birth of this mysterious object. But in reality, Betelgeuse is too light to become a black hole. Most likely, after the explosion, it'll turn into a white dwarf that will gradually fade until it becomes invisible.